we have a list of movies, all right? And each movie has like the title, the studio, the runtime, okay, the release date, the year. If we want to find, then we might want to ask some questions. Like, for instance, maybe we want to find, like, what's the average length of movies, like, per year, okay? So all of a sudden we need to, like, change what I keep saying, like, the dimension of the data. Meaning we need to go from a row for, one row per every movie to one row per every year. Whenever we want to change dimension of the data, like, the only thing I think the only thing I know of that does that is group by, right? So if we want to go to each year being a separate row, I think we have to use group by. Okay, so let's try doing that. So do select the year, right? I want one row per year. And let's say the average the average runtime of each movie from movies grouped by the year. All right. Okay, that seemed to have worked. Let's say as average runtime. So now we have one runtime, the average runtime per each year. And then we can say, like, if I want to find all the years with a runtime over, like, let's say like 130 minutes, I don't know, having average runtime greater than 130. So these should all be numbers. So I think I'll be good. Okay, so apparently, like, this is interesting, right? Just the early years, movies got shorter, apparently. That seems to be a trend. All right. Okay, so that's kind of one way of doing this, right? Is just using this group by and then having, right? I have to use having because I'm referencing, right? I have to use having because I'm referencing my aggregate. So I have to tell SQL, wait until after we've done the group by year, then calculate the average per year, and then, after you've done that, then find only those movies with an average runtime greater than 130. So another way to do this is with, CTE. So let's talk about that. So what we'll do, CTEs essentially are, like I said, they're similar to subqueries. Functionally, they accomplish the same things. What we can do, I'll just start from scratch. Say select all from movies. Okay? And we'll say select all from movies, group by the year. And let's just say let's select the year, comma, the average runtime as average runtime from the movies grouped by the year. And we can think of this as kind of like this is our first step, right? And then from here, we want to find the average, where the average runtime is greater than 130. So to break this into steps, one nice tool is a CTE. So we can say with, let's call this like average runtimes or average runtime years, runtimes per year as parentheses. Okay, so you can kind of see how we do this. And tactically, a lot of people will break it up like this. So it's this is going to be the name of like my temporary table, right? So we're basically taking this query, assigning it to a temporary table. So with this thing, average runtimes per year, this is going to be my new temporary table as select year, average runtime from movies grouped by year. So what we can do is we can select all from average runtimes per year. Let me put a semicolon there. Okay. So this is the result that we see, right? This select all from average runtimes per year. What is average runtimes per year? Well, it is the result of this select statement. Year, average runtime. One thing to note, right? So I can select year, comma, average runtime, because those are two columns defined here. I cannot select, just like plain old runtime. I can't, if I can type it. All right, select year runtime. That doesn't work. So let's see the error message. No such column runtime and I guess it doesn't tell me the table, but here, right? There's no column runtime in the average runtimes per year temporary table. Okay, the only columns we get is this one and this one. All right, so, you know, that's kind of the procedure. So from here, we can do select year, comma, average runtime. And then we can do average runtimes per year where the average runtime is greater than 130. So this is, you know, accomplishing the same steps. All right, the reason why I can do where at this point is because, you know, here I had to tell SQL, hey, wait until the aggregate occurred, right? To then, you know, do this halving average runtime over 130. In this place, you know, the CTE kind of imposes that sequence, right? In order to select from average runtimes per year, we have to have already performed this select statement. Right? And then the syntax is with, name the new table as parentheses, right? And now this is going to be my new table, and then I can select from it. Notice how I kind of got everything running was, you know, just write the query, wrap it in the CTE, then do select star from the new table, just to make sure everything works fine. Okay, question. We'll make this a little more complicated, but questions about that? Sound good? Right, and then, like I said, conceptually, it is just like subqueries. If you want to think about, well, why do we even have this thing? This is a sequence, right? Like with the CTEs, we can kind of see this as a sequence. If this was a subquery, you know, we would be select star from, you know, this subquery, right? This shows me, so you'd have to read the subquery first to figure out what I'm selecting everything from. This way, you know, syntactically, it follows like the order that the code is actually executed in. This happens first, and then this happens. So like lots of times you'll see people use, like some of you all already probably have in your internships, have seen SQL statements that are like hundreds of lines long, and then they're broken up, right? And they with these CTEs as a way of essentially like organizing the code, wrapping it in almost like functions, right? That's what we're doing. All right, questions before we make this a little more complicated? Okay, so the next thing we can do, let's give ourselves a different problem. Let's say we want to find, I think the problem is, we want to find the studio for each year. For each year, find the movie studio with the longest runtime. Okay, for each year, find the movie studio with the longest runtime. So for instance, maybe in the year like 1950, like Disney is the movie studio with the longest runtime of like, you know, 200 minutes or something like that. And then maybe in 1951, the longest Paramount, which might be owned by Disney, has the longest runtime of like 180 minutes. Okay, so for each year, find the movie studio with the largest runtime. And again, when you're starting with these, you want to think of like, what is the dimension that we're starting with? So it's let's do select star from movies. All right, we'll do df. And I broke it. Select star. Oh, I need the connection. Okay. So what is the dimension we're starting with, right? One row is one movie. So in order even to get, and what do I want to get? Well, I want to figure out for each year, find the movie with the longest runtime. So now the next question I think of is like, this is kind of not a good structure for my data to answer this question. What would be a nice structure of my data to answer the question? Probably if I had like a table, let's call it like studio, you know, runtimes per year, right? That has, you know, Disney, it has exactly this. Disney 200, and maybe it also for 1950, and then we have like also 1950 like Paramount, right? And that has like 180, and then also in 1950 we have Warner Brothers, that has like 190. So this would be nicer, and then I go to the next year, and we do the same thing essentially. All right, because now I can like figure out, okay, once I get to this step, then I can at least answer the question visually, right? We can worry about translating it to SQL later. So this is kind of like the middle step that we probably want to get to. We want to go from one row for each movie to one row for each studio per year, right? So we want to change the dimension. Sounds like a problem for group by, right? Because we're changing what each row represents. So let's do that. Select all from movies. What do we want to select? We want to get the year, the studio, and the average runtime, okay, from movies. And then I want to add, and let's say like as average runtime. And now what do I want to group by? So it's each row is for every year the average for that studio. So I need to group by two things, right? Because if I just group by year, that's going to be, one row per each year. I want year, comma, the studio. Let's see how that does. Okay, so this is showing me this, right? Like this guy, 75 minutes, short films, gravitas, with a name like that, longer films, right? Okay. So, what's nice about CTEs is now we can use, this is like our first step, and we can use the CTE to break this into steps. So say like with, what do we call this thing? Studio runtimes per year. As, wrap the parentheses, and let's just do like select star from studio runtimes per year to make sure that this is operating, like that this just works. You'll notice also syntactically I'm putting like the parentheses here and the last one there. I think this is the normal way. I'm pretty sure this especially. They'll put the beginning parentheses there saying like, essentially like something's coming. All right, and it's this. Oftentimes you'll tab this part in. All right. Okay, so everything still works. We're good. Now what's the next thing we want to do? Okay. What I would do, like we could maybe find the max of the average runtime. The issue with that is like, what if there's ties, Like two studios, you're only going to, that have 181 minutes in 1914, you're only going to get one of them. So instead, perhaps what we should do is use a window function. So here we go. So we'll select the year, comma studio, comma average runtime, comma, and here, I'll just write the word over. All right, and I want to actually get a ranking, right? And that'll give me like 1 here and then 2 here, if these were in order. So it'll be with rank over. And now how do I want to, so this is the table I'm starting with. So this rank should be based on what? Like when do we kind of start over each rank, right? Every year. Right, we want 1 through 10, or top 10, 1, 2, 3, 4, 5, then we go to the next year, start at 1 again. So we want to partition by the year, and then that's pretty good. Let's just do that for now. Okay, so we can see this does not look great. I kind of have an idea as to why. So we are getting like a new number 1. This thing has 2 number 1s, even though the average runtime is different. Do I have to do, yeah, okay. So how am I going to, like, one thing I'm not telling it is what this ranking should be based on, right? It should be based on the runtime, the average runtime. So I think what I should do is I probably need to order by this, right? I want to put these things in order, or calculate this rank by the average runtime. And let's also do that. Okay. So now this is looking better. All right. So it's calculating the rank based on the average runtime. So that's why this one is longer, apparently. I probably should also order by year. Sorry about this. Like order the rows overall by year, comma, average runtime. All right, that so far we're good. Let's just look at more data. Okay. So we had, this is number 1, 75, number 2, 192. Now we're on to the next year, 1916. Here we at least finally have some new years, new stuff. The NAN, that's unfortunate. That's ranked number 1, but we'll worry about that later. And then we have 1, 2, 3, 4, 5, 52, 75, 80, 107. So again, we started by first calculating the average runtimes with our CTE. Then we're giving each studio a rank, right? We did the group by to change to studios per year. And now we use the rank to say, for each year, tell me the rank, and that rank will be based on the average runtime. We're going to kind of group these things or order these things by this attribute in each year and generate a ranking from it. Okay? And then we can just name this then as rank per year, I guess. And now finally, the last thing we can do is, I would like to do where rank per year equals 1. I don't know that we can do that, right? Because we're referencing something that did not, that doesn't exist yet, right? Like you can see it's going to tell me there is no column rank per year equals 1. So again, it's just order of operations. This column is generated before the where clause executes. So in order to impose a sequence, I can do comma, we'll call these ranked studios as, and then put this whole thing in parentheses and see if it works. And then we'll do select star from ranked studios. I just want to see if this works. All right, God bless us all. Okay, so how did we do this? Notice this is different, right, than a little bit different syntactically than the original. So again, we just complete the step, we wrap it in a CTE. So here I'm doing with the studio runtimes per year as, then here's my CTE. We're just doing the group by year studio, and then we did this window function thing. Notice that this time I don't use the word with, okay? You only do that with the first CTE. When you add in a second one, you still do the comma, then just name it, and put the word as in the parentheses, but you leave out that word with, okay? And now I can say select all from ranked studios, and I can just say where rank per year equals 1. All right, and that's my answer. For every year, we're only finding the top movie based on the average runtime. So just kind of the reason why we had to use a CTE here was because we first had that column of the rank per year, and I'm not able to select. I can't do where rank per year equals 1. Here, I have to say, hey, after you generate that rank per year, then find the movie that has a ranking of 1. Yeah, Kayla?
I think you need to order by average runtime descending to get the highest average runtime as rank 1.
That's a good idea. Right, because you're looking at this and you're saying, let's see.
Yeah, we had a longer one up there.
181. 190. This definitely changed the answers. Yeah, this looks better. And we can just let's just make sure, select all ranked. So now we have 181, 75. Wait, this is a different one. Let's order by the average. Let's order by the year, comma, average runtime. Wait, why is this? This is not right.
I think it's right. Rank per year is 2 on the second line, so that's fine.
This is 75. Oh, I see. This is 2. I see.
Yeah.
Yeah. Order by year, average runtime descending. Right? Because if I want to visually, so this is kind of a good point, right? Like this is right. This is showing up. This is what ranking is this per year? It's second place, right? Because Gravitas has a longer thing. But what's confusing, at least to me, is visually, this guy's showing up before this one. So the ranking is generated. In other words, this ranking is generated in the right order because we're ordering by average runtime descending. But the overall ordering of this is determined by this order by, right? This order by here only is ordering for the ranking. It's only determined. Our window functions really only affect the column that they're about. So this is about this rank per year column, but it's not affecting like the overall ordering of these movies. So in order to do that, I should order by year, and that's fine to be ascending. But then average runtime, let's see, that should be descending, right? Which will probably take this 192 and put it on top. I hope. There we go. Okay. And now that this looks good, right, then we can say, remove this and say where the rank per year equals 1. Okay. And if you want to, you can, leave this column out and just say year studio, just not display it by changing these column names, right? So this is still selecting based on where rank per year equals 1. We're just not showing that number, right? Because it's not the columns that we're choosing to display. But we can confirm that for each year, we're only getting one movie. The reading talks about this too, but and goes through this problem. This is a hard problem, but I did want to show it to you because this pattern of kind of generating a rank and then selecting where that rank is 1, that you'll see. That comes up. Okay. In terms of CTEs, key thing, this is just like a subquery. Just place in parentheses. For the first one, have the word with. Tell me what you want to name it, give it as. Then in the next CTE, you generally reference that first one, right? From Studio Runtimes. Okay? And now you do the next operation. Here in this case is basically adding this window function. Give me a ranking per year. And then in the final one, now that we can like kind of scope it down, do the finishing touch. Just give me it where it's number 1. But the point is like we're using this is kind of like we're coercing the data into the structure that we want to answer our question the same way that we did this in Python, right? We get this messy JSON, this messy starting point, change it till it's finally easy to answer my question. CTEs are the same like sequential, change my data in either by dimension, change it by giving me finally a ranking with a window function, right? And then finally, make my problem easy by just give me those where the ranking is 1. So the lab is pretty extensive. Anything to go over about CTEs before I let you all do the lab? Yeah, Bryn?
If they kind of accomplish pretty much the same thing as subqueries or certain types of subqueries, is there a preference in terms of how they're run, like the speed or like
No.
There's no difference? Okay.
There's no difference with that. I say you'll see CTEs like probably more often. Subqueries is more like smaller, almost like not a large operation, like almost like, okay, here's this one little thing, so you can put it in a subquery. But CTE, because it's just like easier to read, because it's sequential, first we're doing this, then we're doing this, right? You'll see people lean on CTEs more because of readability. All right.
One thing that I also want to point out is with CTEs, one of the benefits is you can use it later in your code. So with the subquery, you write your query, you have the subquery, and that's the only place to really reference it. But if you have a CTV above, even when you're further down into like the fourth or fifth like query that you're writing in that stream, you can still reference the top one.
Right. Yeah, exactly. So we could select from, this earlier one if we want to. We could join on, like things like that. But they're just variable. Like I think of them as either like variables or functions. It's a way to encapsulate your code and then give it a name. All right. This is like what we've been doing all the time with Python, right? And now we're finding either these subqueries or these CTEs as a way to do that with SQL. All right. So the point is like, why are they useful? We could, I don't even know if we probably couldn't write this all in one thing, but a good way to think about CTEs is this is a good way to break your SQL into steps, right? The same way like as you get harder problems, like we talk about like breaking Python into steps, as you get harder SQL problems, like break it into steps, wrap it in a CTE, right? That way then you can make it easier, right? So you start with this one, studio runtimes per year, just give me the average runtime per year per studio. That's a good first step. Then we can look at the data, move on from there. All right, now that we have this, let's get the ranking, per year. Find the studio and rank all the studios. Good, that's a good second step. Now if I give you that ranking, fine, just find the top one, right? Like, all of a sudden you just chip away until the problem becomes easy. All right. So I will